Okay, so we do 4.8. So we read this one, L'Hopital's rule. Can you pronounce? Not the L hospitals. We read this one, L'Hopital's rule. Okay? So when do we use this one? Okay, we are using this rule for indeterminate form. Okay, so indeterminate form means we cannot determine, right? Because in there, and determine the answer, such as we have a 0, right? Or number, any number. Any number, or positive infinity, negative infinity, right? Okay, we can answer that, right? Me too. All right. Then we call the indeterminate form. But then indeterminate form has the form. How? This is the form, like this. Infinity over infinity. So this is included there, like a negative infinity, positive infinity, or positive infinity, negative infinity, or negative infinity over negative infinity, like that, okay? So we just say infinity over infinity, right? And also 0 over 0 is also called indeterminate form. And what else? We have more. We have 0 times infinity, or infinity minus infinity, and 1 to the infinity, or infinity to 0 power, or 0 to 0 power. So everything is indeterminate form, but then L'Hopital rule, we're gonna apply only 2 types, infinity over infinity or 0 over 0. Okay, let me write down the theorem first. L'Hopital's rule. So this one only the form of infinity over infinity. So as I said earlier, infinity over infinity means we can include negative infinity over infinity, positive infinity over negative infinity, and negative infinity over negative infinity, okay? And 0 over 0. So only we have that forms, infinity over infinity, 0 over 0, the forms, then we can apply the L'Hopital rule, right? Only 2 things. Now, how? So if we have the limit, so basically we have to have a condition f and g are differentiable. Okay, now if we have, let me just make up 0, 0 or infinity over infinity indeterminate form. then we can say that limit when x approaches to a, f of x over g of x equal to, we do derivative, okay? All right, so we have to know this rule. It must be fraction form. Okay, so in order to use a L'Hopital rule, it must have indeterminate form, which is 0 over 0 or infinity over infinity. Then it must be fraction form, right? Then we can derivative, look, f prime of x over g prime of x, right? Then this means we do derivative derivative f and g respectively, okay? It means no quotient rule. Is it clear? Okay, we don't use a quotient rule because fraction form, okay? So we do derivative numerator, then we do derivative denominator respectively. Okay, very good. Okay, I'm gonna erase this one. So 4.8. All right. Let us do evaluate. I want to do this one first because other one we did in the beginning. Okay. When x approaches to 1, sine pi times 1, right? Sine pi, what do you get? Zero. How about ln x? When ln 1 is 0. Good. Okay. So this is 0 over 0, which is in the determinated form, right? Okay. Then it's a fraction, so that we can apply the L'Hopital rule, right? Then by L'Hopital rule, we can make derivative numerator, derivative denominator. Let me do this way. Respectively, right? So with derivative sine pi x, what do you get? Sine pi x?
Cosine pi x times pi.
Excellent. Chain rule, right? Okay.
Yeah.
Now, with derivative ln x, what do you have?
1 over x.
1 over x. Very good. Okay. Now, we plug in. So when x approaches to 1, pi cosine pi times 1 over 1 over 1. Then what do you get? Cosine pi, what do you get? -1, good. Which is negative pi. Very good. This is the answer. All right. How about second one? How about this? Limit. When x approach to positive infinity, e to the 1 over x minus 1 over 1 over x. Okay. So we have to know casually thinking 1 over infinity, what do you get? So we have a number divided by bigger number.
Essentially 0.
Very good. Okay, so we should know that. So then when x approaches to positive infinity, e to the 1 over infinity, right? So very good. So this will be, so casual thinking, e to the 0 power minus 1, which is very good. So 1 minus 1 equal to 0 over 0. Okay, so indeterminate form. Very good. All right. Now we're gonna apply L'Hopital rule. So that is numerator, denominator, respectively. So what do you get this one? Numerator.
I think it's just e to the 1 over x.
E to the 1 over x. Then Chandler. Don't forget Chandler. Okay, thank you. So we get e to the 1 over x, then minus x squared, right? Good, very good. Okay, how about the denominator? Okay, thank you. So you guys participate very quickly. Thank you so much. All right, then let us simplify. Yes, thank you. You guys really quick. I cannot follow that. So we have e to the 1 over x. Now we know that e to the 1 over x, when x approaches to positive infinity, that is e to the 0, right? Sorry, a little bit like that, okay? So we get e to the 0, which is 1. Okay. All right. Let me erase this one. Okay, how about this one? Evaluate. So this is what we did last time. So very similar. Okay. When x approaches to positive infinity, what do you get this one?
Three halves.
So we have infinity over infinity, right? Then infinity over infinity, then we can apply the L'Hopital rule. So we're so fast today. So we do derivative. And she said the answer already, right? So we get 3/2. So we have 3/2, right? So she said that 3/2. So I gave you a tip last time, right? If x approaches to positive infinity or negative infinity, we take the dominant term, right? From numerator, denominator, respectively, right? Then there is approximately, so like a example, we have 3x. So dominant term, which is 3x over 2x, right? Then we get 3/2 because of this reason. Okay. So x approaches to positive infinity. Okay. All right, second one. Limit x approaches to 0 from the right. ln x over cotangent x. Okay. So if you're not familiar with the graph, you can use decimals, right? All right, so ln x, so ln 0 from the right. From the right, what do you get? Good, negative infinity. Okay, how about cotangent x? Cotangent x is cosine over sine, right? Then we have opposite way like that, like opposite way with a tangent, right? So from the 0 right side, what do you get? It's positive infinity, very good. So this is a consider like a infinity over infinity, right? So negative infinity over infinity, right? Then we can apply the L'Hopital rule, right? So then we do derivative respectively, numerator, denominator. So what do you get the numerator?
1/x.
Very good, thank you. What about the denominator?
Is it cosecant squared x?
Negative cosecant squared. Very good, okay? All right, so that means, let us simplify. This means we keep the first fraction and reciprocal of second fraction, that is times, so that is over 1, right? So it will be 1 over negative cosecant square x, right? Same as, right? Now we should think 1 over x so what do you get this one? When x approaches to 0 from the right, then x from the right, which is 0, right? How about negative cosecant square x? So we need to think, let me erase the left side. Let us think. This one first, cosecant x. Cosecant x. So cosecant x, which is same as 1 over sine x, right? So 1 over sine x, which is sine start 0, like that. And asymptote cosecant x will be like this, okay? There's no space to document. The blue one is cosecant x. When x approach to positive infinity, from here, what do you get? So the graph is like that. What do you get this one? So hold on 1 second. Let me draw a little bit bigger. So I'm talking about cosecant here, okay? And when x approaches to positive 0, when x approaches to 0 from the right, then what's the cosecant x?
Positive infinity.
Infinity, right? Then squared,
Yeah.
squared, right? So we know that, okay? Now, we know cosecant square x is the same as 1 over secant, 1 over sine square x, right? So then we have, let me just rewrite this one. Okay, then look, this will be nicely sine square x. And then look over negative x. Do you agree? Yes, good. Okay, now when x approaches to 0 from the right, what's the sine x? We dealing with the square later. What's the sine x? It's 0, right? 0 squared, which is 0, right? And we know that when x approaches to 0 from the right, negative x, which is also 0, right? So this will be 0 over 0 again. Okay. So we don't get the nice number. If we get the nice number, 0 or any number or positive infinity, negative infinity, then we don't say that it's an indeterminate form, right? So we say the indeterminate form has 0 over 0 or infinity over infinity or infinity to the 0 power, 0 to infinity power, 1 to the infinity. So I wrote down the list earlier, right? So here we do derivative, numerator, denominator, respectively. So sine square x with derivative, what do you get?
Cosine squared x.
Okay, this means sine square x equal to sine x quantity squared. It's a different story, isn't it? With derivative, what do you get?
Oh, I see. It would be 2.
Very good.
Yeah, cosine squared x.
We get 2 sine x. Because power rule, we have to use that. Then we do chain rule, derivative of sine x. Okay. How about the negative x? What do you get? With derivative of negative x. -1, very good. So we have not done yet the chain rule, so which is cosine x. All right, now we substitute. What do you get? 2 sine 0, cosine 0 over -1. So what do you get? This one. We don't have to calculate anything, just sine 0, right? Which is excellent. Okay, it's 0. That is the answer. It's good, huh? Okay. Otherwise, we have to using the algebra work. We did that in the beginning of chapter 3, right? We try to find indeterminate form. We are using multiplying by conjugate and so on, right? Okay, let us do other indeterminate form. Let me erase this one. So if we have this form, when x approaches to 0 from the right again, in this case, and we get x for 0, right? What about ln 0? ln 0? We cannot do that, right? Because must be 1. ln x, we need to analyzing graph. From the 0, what do you get? When x approaches to 0 from the right, what about the ln x?
Infinity.
Yeah, negative infinity, right? So this is also indeterminate form. Okay, but then in order to use the L'Hopital rule, we have to have a fraction form. Then look, do you agree this one? Do you agree? It's the same as? Yes, good. Now, then when x approaches to 0 from the right, ln x, we know that negative infinity. When x approaches to 0 from the right, 1 over x, like this, right? Then it's a positive infinity, right? Okay. So it's a negative infinity over positive infinity, which is indeterminate form. Now we can use L'Hopital rule, right? So we do derivative, numerator, denominator, respectively. So ln x, what do you get? It's 1 over x, very good. How about with derivative negative 1 over x? It's negative 1 over x squared, very good. Now we can simplify, so x with 1x there, right? So it will be 0 from the right. So we will get 1 over 1 over x, right? Negative x, right? So this will be negative x. So when x approaches to 0 from the right, what do you get this one? We know that this is when x approaches to positive, not positive infinity. When x approaches to 0 from the right, what do you get? Easy. Thank you. 0, right? Okay. All right, so since I have a space here, let me talk about the indeterminate form. There's no D, right? That's why your classmates make that the question in grammar mistake, indeterminate form. Okay, infinity minus infinity. This one, the answer is a change. It depends on problem. So let me show you. Type 1, limit. When x approaches to positive infinity, we have f of x minus g of x. Then the f of x is going faster than g of x. Then we get the answer as positive infinity. Okay, for example, like this. Okay, so we read this one, and then which one is more faster? X cubed, right? In this case, it's a 3x cubed. Then when x approaches to positive infinity, we have positive infinity there. Okay, in type 2, when same concept, but then what if they go fast same way, right? So they say that this example, like 3x squared minus, that is the f of x for the 3x squared, and then g over x will be 3x squared minus 5. Okay, so f, this is g, this is f, this is g. Okay, but then look, it's a 5, isn't it? Negative 5, right? We calculate before we apply the limit. Very good. And type 3, what if this time is g over x go approach, goes or x goes to positive infinity much faster than f of x, right? Then, for example, like this. Okay, look, this is f, this is g. Then we don't care what other things. We're looking at the negative 3x squared because x approach to positive infinity, then that is the much faster approach. Reach there, right? Positive infinity. Okay, then what do you get? We get negative infinity because we have a negative sign in front of negative 3x squared. Okay, so look, every answer is different. It's not fixed, right? That's why we say that infinity minus infinity also the indeterminate form.
Wait, why were each three of them different? Like we're focusing on a different portion of the problem?
No, because I am explaining to you this infinity minus infinity is indeterminate form.
Okay.
If this is determinate form, must be fixed number or infinity like that. Is it clear? We cannot have a 3 different answer. This is
Okay.
determinate form. Okay. All right, let me erase this one. So basically, infinity minus infinity, it depends on last type. So last type, the type number 3, it's about f minus g over x. So in this case, g over x is approach to infinity faster than f of x. Okay. So type number 1, f over x approach to the infinity more faster. Okay. But type number 3, g over x approach to infinity more faster than f. Okay. Well, it's a subtraction, right? So we have a negative. Okay. So we have a x approach to positive infinity, but negative sign there. So it's a negative infinity. Okay. Or we might think about negative 3x squared, like a parabola, open downwards, right? When x approaches to positive infinity, the graph goes to negative infinity, right? Okay, let me erase this one. Okay, let us do 2 more examples. So evaluate. This author like 0 from the right. Okay, 1 over x squared. This is like that, right? So when x approaches to 0 from the right, what's the 1 over x squared behavior, basically? It's a positive infinity, good. How about 1 over tangent? 1 over tangent is pi over 2 there, right? And then like this. When x approaches to positive infinity, I'm sorry, when x approaches to 0 from the right, what do you get? It's a negative infinity, so how do we do? 1 over, so this is like a, one over negative infinity. Or to get this one. Do we get this one? Easy, we have a form of 0 times, right? So 1 over negative infinity is also indeterminate form, right? Yeah. So now let us make a common denominator for this one. This is a technique, okay? So common denominator is x squared 10x, then 10x minus x squared, okay? Now, oops, let us think more. Okay, when x, let me do it. When x approaches to 0 from the right, then 10x, we have 10x, which is negative infinity, and minus x squared, which is infinity, right? And what do you get? What do you get? The x squared 10x. So x squared is positive infinity. Oh, too much. And 10x. Let's see. Let me see. Okay, I made a mistake here, right? So can you please change this one? Like this, isn't it? Is it correct? Right? Okay. Then when x approach to 0 from the right, what do you get? We get 0, isn't it? So 1 over 0, what do you get? 1 over 0. So 1/0 means 1/0.000001. Very tiny number. What do you get? What do you get this one? Infinity, right? Okay. Very good. Infinity. Okay, now I don't know why I put this one, even though there's a subtraction. Weird. Did not think about that. So we have infinity, infinity minus infinity, right? Okay, then let's see. This is numerator has 0 minus 0 because x squared, right? I don't know. I was thinking crazy. And then denominator, we have x squared, 10x, also 0. Okay. Now, we can apply L'Hopital rule. So numerator, denominator, so what do you get this one? Numerator with derivative.
Secant squared x minus 2x.
Very good. Wow. Denominator, we have to use, okay, we can use a product rule in this case because two function, right? In here, it's okay. So inside the numerator, inside the denominator, we can do that. We can use a quotient, we can use a chain rule, but not like a fraction. At first, we cannot use that. We must use L'Hopital rule as numerator, denominator separately. Okay, so this is f g, then f prime g plus f g prime. So what do you get this one? F prime
2x.
x g 10x plus f x squared. G prime, what do you get?
Squared.
I'm sorry?
Secant squared x.
Secant square x. Very good. Okay. Now, secant square x is the same as 1 over cosine squared, right? So when x approaches to 0, what do you get?
One.
1, right? So 1 over cosine 0, which is 1. And there's a square is 1, right? So polynomial, we can do that. 0, 10, 0 plus 0 and secant 0. Then 1 minus 0 over 0 plus 0, right? You see? Okay, then what do you get this one? What do you get this one? So 1 over, go ahead.
Infinity.
infinity, right? So 1 over 0 means 1 over 0 0.00000000001, very tiny number, okay? Because some people say that, oh, undefined. No, okay? So 0 in denominator means it's 1 or any number divided by 0.0000000. Stop me. 0.0000001. Very tiny number. And we get the infinity. Okay, so casual thinking here. We should know that. Okay. 1 over 0, which is infinity. Any number over infinity, we get 0. Okay. All right, so one last one. Let me erase this one. Okay. Indeterminate form, which is infinity over to the 0 power. Okay, look. We have infinity, right? And 1 over infinity. Casual thinking, okay? What do you get? Infinity. 1 over infinity, what do you get? It's 0, right? This is 1 over indeterminate form. Then we have a power, then we know the process, right? So we take the ln both sides. So before we do that, rushing again, we say that let y equal to only x to the 1 over x, okay? All right. I want to say just the whole thing, limit. Okay, let's take the ln y. This technique, we know that, right? Okay, then we know that we bring down the power. That's why we need to take the ln, right? So let us do this. Okay, now I want to switch this one. Okay, now I want to switch more. Okay, so I can rewrite this one, ln x over x. Okay, now let us apply the limit. So when x approaches to positive infinity, the ln x is infinity, then infinity, right? So infinity over infinity, which is indeterminate form. Now, we do using L'Hopital rule. So what do you get this one? ln x with derivative. Derivative of ln x,
1 over x.
1 over x. With derivative of x, what is it?
1.
1. So then we have 1 over x, which is 1 over infinity. What do you get?
0.
0. Very good. Now, we said that ln y equal to 0, right? Now, we want to know about the only y, okay? So then we take the e, opposite of taking ln, right? So we do take the e, both sides. Then we simplify e and ln, so we can bring down y, e to the 0. We know e to the 0, which is 1. Okay, so then what's the y? Why we say that? Y equal to this, right? Okay, so we have the question. Limit x approach to positive infinity, x to the 1 over x, which is 1. This is the final answer. Okay? Let me erase this one.